Civil engineering, both are over, and excuse me, sir. Sir, I would like to let you know that the suggestions which you have made, and the title is Street Mapping with High Resolution Satellite Imagery under the supervision of Dr. Urmila Shravanka. The second one is by a PhD scholar, Mr. Prashant Borkar, on the very topic Design and Development of a System for Traffic Density State Estimation using Acoustic Signal and its applications in Intelligent Transportation System under the supervision of Professor M.V. Sarode. And one is by Mr. Dharmendra Yadav on the topic Design and Implementation of Novel Approach for Information Security Risk Analysis in Smart Power Grid System under the supervision of Dr. Anjali Mahajan. So, can we begin with the first presentation by the Mr. Scholar? Yeah. Okay.
This is pre-submission seminars. After incorporating the suggestions which are given, then the candidate will submit the thesis to the university.
I am doing my MA by research under the respected guidance of respected Dr. Urmila Shravanka ma'am. And the topic of my research is street mapping with high resolution satellite imagery. As we every 6 months we see that every new satellite has been sent in the orbit. So what these satellites are doing, there are various satellites like remote sensing satellites, and these satellites are taking the pictures of Earth. So every now and then we are seeing that satellites are being sent. So these satellites are capturing the data of the Earth, like water body, forest, buildings, etc. So for the researchers, it is a challenging task that how can we extract the data from the images. But images are also of different types. The resolution of the images again it varies. Like the remote sensing images are having a resolution of 30 meter to 1 meter. So we get the image of 30 meter also, we get the image of 23.5 meter resolution also. And continuous research has been going into this and decreasing the resolution of the image by centimeters. So there are so much resolution. So it is a challenging task to extract the data from the image. So in this research work, we have done semi-automatic extraction technique for identifying the features from the satellite image. So in this, we are using the high-resolution satellite images. Then we are mapping the street, water body, settlement, etc. Then we are doing the feature extraction. Then after getting the features, we are clustering. And after getting the clusters, we are classifying those satellite images based on the cluster range values. And after getting the classes, we are vectorizing that and creating a map. So that will be in the most real-time and readable format. So in this, you can see that on the right side there is an image, satellite image. This is a image taken by the satellite, and this is of LIS-3 image. So LIS-3 is nothing but linear imaging self-scanning scanner is there. So it is having the resolution of 23.5 meter resolution. So you cannot identify what is this image contains. So for a general user, so for planners, for engineers, and for application developers, they have to understand and they have to get the features every now and then. So there are various features belonging to this image. So we cannot identify what is that color, red color. So I have shown here that red color shows the vegetation, and the RGB value is just like this, 185.13.204. But the front, the person doesn't understand. So these values, so they identify from the colors. So the tree is having that much of the RGB, then water body is having that road, open line built up. So there are so many features like this. So this is the model in which step-by-step procedure in which I have done my research work. The first one is the input is the satellite image, like high resolution satellite images. Then we have done the radiometric correction by doing pre-processing. Then enhancement, then stretching is done. Signature generation in which sample clusters are formulated. Then maximum likelihood classification is done simulated. Then fuzzy inference system and membership function and outputting the clusters. So these are the aims and objectives of my research work, identifying the color of the objects like water body, land, road, etc. from the maps. then identifying the signature from the target image, clustering of signatures, framing the rule, classification of the sample, fine clustering, then automatic clustering of feature clusters from satellite images, then vectorization of classified image output and map generation. So in the problem definition here, what we are doing here, there are due to man-made changes, maps are changing automatically. So the drawback of this is that so many features have been updated. Like there are natural changes also, there are man-made changes also. So buildings are there, roads are there, whatever. So these changes are need to be identified in the image, and the planners needs that change. What are the changes? So they have to identify it very urgently and very frequently. So that needs to be done here. Then another aspect is that natural changes in the environment such as forest, vegetation growth is there, forest growth is there, tree cutting is there, needs to be extracted. Then for this we are doing clustering. Then with the fine clustering of satellite image, map needs to be updated, then updation of the map is needed. So these changes are reflected in the image as location of buildings, new and damaged roads, area, water body, etc. So these are the literature survey have been done. So these are the various techniques which have been identified from 1994. Nagai-Matsuye approach, in which classification of high resolution satellite using Nagai-Matsuye approach has been done. Neural network, fuzzy fusion, satellite image analysis. Then area morphology, we have some use the area morphology technique. Then pyramidal segmentation, morphological operators, hierarchical fuzzy classification you have used. So similarly, there such research has been going into this field. So these are the techniques: textural and contextual features, object-oriented, multi-scale structures, and modified differential evaluation K-means. Then in this there are so many satellite images are like that. Iconos is there, hyperient data is there, in which the number of bands increases. So as much as the band you increase, you get the data very sharply. So this has been implemented by using the simulating tools like Radars Imagine 2430 for image processing, then RGS standard for vectorization, Visual Basic Programming, MATLAB and signature editor for creating signatures. So these are the parameters which we have taken in from the image. Like in the image there are three bands like red band, green band and blue band. So these are the clusters, for example like tree, water body, major or built-up, minor, roads, pathway, etc. So in the red band we are having the standard deviation and the mean. So these are the standard deviation and these are the mean in each band we have calculated. So this is the image which has been taken, and these are the specifications of the image. What is the file type, number of layers, size, width, data size, pixel size, projection and number of bands. So in this radiometric correction filtering is being done using the standard filter. So this is the image which is given as an input for radiometric corrections. So when we get the image, when the satellite captures the image, it does not capture the actual data from the image. There is some errors into that. So that needs to be corrected. So in that we have corrected and we have used the standard filter. And before the standard applying the filter, then in the input image the mean was this much. Then after that we have reduced this mean. Then minimum value parameters are taken, maximum parameter and standard deviation has been calculated. This is the tool which has been used for calculating these parameters. Then we have enhanced the image. Enhancing is again a challenging task because the image quality of the image depends upon the how that data has been captured. So in what are the stretching techniques we are applying to that? As much as the image will be enhanced, that much of the features will be extracted from the image. So we have done here in the features we extracted and we have done stretching here, and you can see there are some features in this image which are looking very blurred and which cannot identify that. So we have applied the stretching technique here, and after that we have got this type of output. So this is the feature which has been output. This is the building, and these are here also buildings, and there are some here roads, structures like this, and here you can see some enhancement is done here. So this is the tool which has been used. So while doing for stretching, we have used the decorrelation stretching. In that internally principal component transformation has been done. So in that first principal component transformation is done, in which we calculate the number of the best principal component. So out of the three bands, so what is the first principal, second component, and the first component we get the image which will reflect you the complete brightness features. So which are will be inputted to the classification simulation algorithm. So these are the principal components which are calculated eigenvalues and eigenvectors. Then we have to create the signatures. Like first of all, we have defined what are the desired classes you are expecting, and for those desired classes we have to collect the training examples. Then after getting the training examples, we have to generate to derive the signature which are subsequently used to classify the image. Then generate the single signature file from a fixed set of input parameters. Then the signature is evaluated by signature derivation and refine the signature to improve its performance. So this is the way how I have developed the signatures. We have taken total images taken 12 and total images for testing 100. So this is the image in which you can see that this is the vegetation class in which we have marked, and this it contains red color of tone. So this is the, here you can see the roads are there. So the texture roads are tone, you can see what is the color and all that. So we have to decide what are the desired class, and we have to develop the signature based on that. So as much as the signature will be distinct from each other, that much of the output will be accurate. So for roads, for water body, for vegetation, for build-ups. So likewise there are so many features. So we have tried for this. Then we have to estimate the population strategy, like what are the parameters of the signatures will be there. Like what are the major roads, what are the minor roads, pathways and build-ups. What will the mean and standard deviation. So this is the tool what we have used, signature editor, in which we have to develop the signature from the satellite image. Likewise vegetation, then field, settlement, classes. Then in this tool we can generate definite signatures. Then we have simulated these parameters by using the maximum likelihood algorithm, in which we have calculated first the prior probabilities of all the clusters. Then initial probability of class K is calculated by this formula, equation 1. Then we have calculated the probability P of x by I of pixel belonging to cluster I by the equation number 2. Then probability density function is calculated by equation number 2, and likelihood estimation is estimated. So these are the parameters what we got from the minimum, maximum and mean and standard deviation of the sample cluster. Then we have inputted this, we have evaluated these values by putting them into the fuzzy inference system. So in this fuzzy inference system we have decided the rules, and we have formulated this type of architecture in which first we have given the input image, then the input image is divided into maximum likelihood classification of the image, and these are the desired output which we are expecting, major road, minor road, pathways, build-up and others. Then we have calculated the numerical values, then output variables are decided and representation is done. So these are the rules which we have framed here. If B is given, then ID is given, then blue is given, then cluster is vegetation. So likewise for all the desired output classes, we have developed such type of rules. So this is the simulation tool for supervised classification, in which the input is given, and output signature file where we have generated the complete signatures are inputted and attributes are calculated. So these are the results of classification image. So this is the input image in which, output image in which we are getting such type of features. This is the cluster 1, this is the cluster 2, cluster 3, cluster 4. Cluster 1 is the road, and cluster 2 is buildings, and the colors and the symbols are depicted here. This is another input which is this image, and this is type of output we are getting. So here vegetation was this, but the clear vegetation is not coming here. Some part is, we got in the result output. Likewise water body is coming clearly, and other features like streets and roads are coming with the sand color. This is another image, this is the Iconis image, this is the output. This is the Google image. We have also tried with the Google image. We have downloaded the image from the Google snapshot, and we have also tested with this. So this is the spot image. And also we have tried with several other algorithms also, like same inputs we have taken with the maximum likelihood, then minimum distance to mean algorithm, then Mahabali's distance algorithm, and fuzzy. So these are the various outputs, and we are saying that there are so many changes what we are expecting here. Likewise for Google also, for maximum likelihood for minimum distance and for Mahabali's distance using. Similarly for spot image, the output is like that. In this also the image we are not getting the complete this output, but still some parcels are being allocated. So these are the percentage of area which has been covered in different classes. This is a graphical representation of the values. So after getting all the values, we have to generate a map. So this output, what we get here, till down here we have these. So after getting this, we have to develop the vector image. So from the vector image, there are so many errors into that. We have to remove that errors. Those are called angles, and clean and build those errors. And after that, we have to union these values and refine those values. And after that, we get the such type of the output. So it is the union of reference vector data with output from the raster 2 vector. So it is concluded from this that the Iconos data shows better result as compared to other satellite images, and Spot and Google shows few features, but some features are suppressed and represented by small number of pixels. For mapping of states and other features, Fuzzy-based classification is found to be suitable. The overall classification depends upon how correctly the training samples have been taken, and signatures and AOIs are required to be distinct from each other. So the quality of the output depends upon the image enhancement and stretching parameters which are to be taken care of before processing. The Fuzzy-based classification algorithm shows satisfactory results for classification features to high resolution satellite imagery. So these are the various applications where we can use this algorithm, like hydrological applications, soil mapping, land cover classification, forest regeneration surveys, lake water impervious surveys, aquatic vegetation surveys, forest health and storm damage. These are the feature scope in which the work can be extended to other digital images also, which are the new satellites which are inside, and the resolutions that we are getting very high, and in the capacity of the centimeters. Like the latest satellite what was sent is now 0.5 meter resolution. It is the foreign satellite, so that is already not available in India. So we have to purchase from the abroad. So for this we have downloaded the data from the NRSC, National Remote Sensing Agency. The data is available freely on that. That is the list 3, 25 meter resolutions. And this work can be extended to other digital images, then considering the multiple scale parameters such as length, texture, shape, size and classification, and work on different bit images. So here the bit also matters, like 8-bit image comes when we get the data. So it is captured in bits, like 8 bits, 16 bits, 10 bits. So the algorithm and the tools also support that bits. It can further be improved so as to achieve more fine clusters, and it can be thought to incorporate content-based image retrieval with some modification, and it can be further extended to work on the improvement of the performance of the system. So these are the publications. Actually, so this work has been, this is the definition given by the Maharashtra Remote Sensing Application Center. So it is the definition given by that. We have worked there on site, working on that. So data has been provided by them. Some data we have downloaded. This is the complete methodology. Thank you, sir.
So from your side, you have done all that you wanted. Is that the correct statement?
Yes.
So can you highlight where you think your contribution is most significant?
Yes, sir.
So it's been an experimental work. There's a lot of some.
Yes, sir. There are various steps in which, sir, I have shown you the steps of my implementation. So from starting from getting the satellite images, so developing, collecting the satellite data, then high resolution data. Then in that we have my contribution is that we have enhanced that images. So every time we have to get the image and enhance pixel by pixel values. And this is one contribution. Second is creating the signatures. It is very difficult to get. what is the we are expecting from the image. So like we are expecting water body, road, buildings, features. So developing those features, we have personally gone to the various locations and we have observed those buildings. Then we have seen how that buildings are looking into the images. So then we have developed the signatures. Then after developing that, it is not like around 20 signatures. We have developed around 100 signatures for each and every features. And along with that, we have same thing has been done for so many other data also. So that is the one aspect. Then again, the second thing is we have developed some task for stretching. So in that stretching, we have used a combination of decorration, stretch, enhancing, filtering. So this is my contribution. So and in the MATLAB fuzzy inference system, I have implemented.
So take any one of them and you have to explain it to me because I didn't get all the material before coming here.
Okay.
So I'm reacting right now. So you talked about signatures.
Yeah.
So can you sort of quantify in what way your signatures, whatever methodology that you have developed, is different than let's say what others would do?
So actually, what I have done here is that.
Is it an experimental, purely experimental driven signature classification, or you have some theory also, which can?
It is purely experimental.
Purely experimental. Okay.
So it is not certain actually. It is uncertain. So we have tried to bring certainty into that. So how exactly? Because the output depends upon the signatures. How you are accurately developing your signatures. So for that, I have tried my maximum levels to quantify those signatures and all the signatures what we are outputting. Like suppose building is there, so building signature is one signature, then a road signature is there, then forest signature is there. So this signature should be very distinct from each other. So that I have contributed to that.
So just from my knowledge, for example, there are huge buildings and there are small buildings.
Okay.
How much difference would there be in the signature correspondingly in the same class? Let's stick to buildings.
So when we see the buildings from the top, actually the buildings area will be the same, sir. So whether it is tall or whether it is short.
Even broad.
Even broad also. Suppose you look the building from the top, it will be appearing as a white color tones or some grey color tones. So, but there are some building structures are also there which are of different constructive material.
Yes.
Used like some cement buildings are there, so that will be appearing as a bright white. And suppose if you go to the slum areas, you will see some rooftops are there, so that texture will be and the color tone will be different. So I have distinguished between them.
Okay. So do you have a catalog of that? Your final signature, because that could be useful for others, right?
Yeah.
So the 100 signatures that you develop, do you have in one place all these signatures over there? So one would like to know how distinct are they? It's possible that there are some signatures which are very close,
Yeah.
but they are completely different features.
Yeah. We have experienced that also. So there are some signatures like some mixing is there with the pixels. So for that mixing also, we have to go into the fuzzy and discriminate those overlap. So we cannot remove the complete overlap because the images are not having the complete dark and complete bright pixels.
Correct.
So there is a mixing of that. So we have also inculcated into the fuzzy inference system. Same thing. So we have minimized the overlap between the different pixels.
So in the process, do you get some negative results? The reality is something.
Yeah, negative results we are getting because we are not getting the 100% output. So here some signatures what we have developed here we are getting the output, but we are able to say yes what we have expected that we are getting. But it is not that suppose one parcel is there, area is there that should be appeared in the output as 100%, but we are not getting that. So we are getting up to 50 to 60%, 70% of that. So we can now again enhance that technique.
So basically, after getting the signatures, you are trying to figure out, you are trying to extract based on the signature, right? And you have some conclusive evidences as to how many times you got this reasonably close. And, it's always good to look at the negatives. When you did not get, what was the reason? You don't have to make it perfect,
Yeah.
but you could explain those instances
So
where
in that,
it was not
actually,
accurate.
in that what happened, actually the classes that we have taken, and when we have developed the signatures, so we have got the mean and the standard deviation. But for other features that we have got, so that also mean and standard
Can you
deviation.
show me the mean
but
standard
there was-
deviation slide? You had a slide there. Can you show it back again? Way in the beginning.
This one?
Yeah. So in some cases the standard deviations are fairly high,
Yeah.
right? And this is where it might infringe into something else.
Yes.
So for example,
Right.
491 plus minus 97.5 and 433 plus minus 36 is almost getting overlap.
Mm.
So major road and pathways
Mm.
can get mixed up. So that's what the data says.
Yeah.
It is like that.
Yeah. So for that also, that only, sir, we in the fuzzy inference system, we have used the fuzzy rules. So we have modeled that fuzzy rules according to our desired output classes. So in that, for a Gaussian distribution function, the input is given as the mean and the standard deviation. So for that mean and standard deviation using, it tries to minimize the overlap between the two classes. So there what happens, the image contains various bands, like red band, green band and blue band. So actually the overlap comes into the bands. So not on the complete image what we are looking at. So
in the individual parameter.
yeah. So in that band we have tried to minimize that overlap.
So you developed the model using some known satellite images, right? Which was given to you.
Yeah.
How many unknown ones did you try, which is nothing to do with India or wherever the data is from? Suppose they take it from Ireland or Siberia or whatever. How does it look? So you make the system learn from some images.
So we actually I could not get the data actually.
They are
So
not
the
available.
data is very restricted actually. Maharashtra was sensing government of Maharashtra. So getting the data is a very huge variety task.
So what variety did you get from Maharashtra region?
So here actually we have got the first Ghrce 3 data is there. So and then Iconos data is there. Then for as you said, for different data, for different data we have got the Google data. We have got the snapshot from the Google and we have tried to do that. So we have also got the results into that.
Yeah. So you said your contributions are not on the experimental side, but on the formulation side in signature and stretching. This I could not follow. Can you explain this stretching thing a little more clearly? What is stretching? And what is
Stretching is here what happens, suppose one image is there. So that image contains various unwanted noise which is not required here.
Okay.
So for by using the stretching, what happens in the image there are various bands like red band, green band and blue band. Actually there are 4 bands actually. So here we are using only the 3 bands. 4th band is not required. So by using this band, what happens, we have to get the output which will be the best output. Like what are the brightest feature which will acquire from the image, considering compositely red band, green band and blue band. So there is a noise in the red band also, there is a noise in the green and the noise in the blue band also. So by using the stretching techniques, the decorrelation stretch is there. So which enhances the image very deeply, and it gets you the output as a features which are very very bright and which are very identifiable. So means I can identify that this is the road and this is the building and this is the reservoir. So it will be facilitating me to distinguish the signature from each other.
So you are suppressing something and highlighting something.
Yeah. Because my task is to get the features from the satellite image.
Can you show me one of those images which you showed in the beginning? Any one of them.
Yeah.
So one single image. Yeah, that's it. So you have got the actual RGB data, right? For
Yes,
this when you
yeah.
start processing. Your
Yeah.
input is the RGB
Yeah.
data. So when you start looking at it, how do you even identify the regions? How do you break it up into different regions? I mean, are you doing that or you don't?
Actually, sir, this is the image.
This is a full image.
Yeah, we are saying that this is a red color, this is a cyan color, this is a
But
black.
how do you do? You start from one end and start examining the entire
Yeah.
image bit by bit?
Yeah.
Okay.
So actually what happens, this image contains the GPS values.
Correct.
Global positioning values are there.
Correct.
So,
That's also there.
so we, this image we have to bring into the geographic information system, GIS, where it is having the projection parameters.
Okay.
So we have to overlay this image into the GIS system. After allocating that, we will be able to see that where this image is fitting
Okay.
in the globe.
Okay.
So then overlaying that, we can identify that, we can switch it on and off. Then we can see at the backdrop that what is the feature here. So here by seeing this, we cannot say that what is this is the vegetation, this is the.
Yeah, correct.
Unless you go to the field and observe that, then only you can say that this is the building or this is the road. There may be a confusion into that.
But the resolution here is not very high in the sense, you know.
Yeah,
you said
resolution of this image 23.5 meter resolution.
23.5 meters. That's pretty big area
Yeah.
in the real life.
So 1 pixel of the ground by 23.5 into 25, that pixel will be of that much of the size.
one single pixel.
Yes, single pixel. So we have tried with the 23.5.
So do you
then
have to do any processing or you got ready-made tools to do this part?
no, we have to do processing, sir.
You have to do even that on
yeah,
your own.
radiometric corrections we have to do that. So this is the image. Another image what we have used the Iconos image, that is the 1 meter resolution. So we have decreased the resolution. So there are some features which
So
are.
when you say you have got a tree area or a vegetation area or a water body, do you also have to identify the portion where it is located? You have to also give the GPS coordinates in your output?
It is for validating, sir. It is for
Okay.
accuracy calculation whether what we got is accurately what is that or not for that.
So what will you give about this whole picture? In summary, what your output of the system will be?
My output will be suppose this is the city area. This will be a settlement.
So you will say there is a settlement.
Exactly.
But you will not say how much, where density. Is that also?
Yeah, that also can be calculated, but we have to append the GIS parameters.
Currently, it is not your concern. Let's say, right?
Currently, we have to the output what we get in the pixel format. We can calculate the area from the pixel also.
As it exists, what is the output I want to know?
So this will be a settlement. This will be a water body. This will be vegetation. So there are some roads which are visible because since this is the image which I have 23.5 meter resolution. So the roads are not visible clearly.
Correct.
So if I go to the 1 meter resolution, I can see that resolution. So here you can see some river is going on here. This is the Nagpur city, sir.
This is Nagpur city.
Yeah. So main aim is mine to create the map from this.
So you have said applications of your result will be a lot of applications.
Yeah.
Can you pinpoint and say where it will be really very accurate or good? You don't have to give so many applications. Nahi chahiye.
Yes.
Take one or two and say where you think your model will be more accurate than others. Yeah, these two main.
Actually, as I said, we can use this in so many applications, but as you said, the most proprietary fitting will be in the land cover classifications.
What is
Why land cover? Because the land cover means the features which are covered by the land. Like forest is there, water body is there. These are very sensitive area and these are very much needed nowadays. What is the capacity of that and what is the volume into that water bodies. But considering the forest and all that, so it consumes a lot of area. Area is bigger, sir.
So let's take land cover only. Suppose you are doing a good job of
Yeah.
land cover classification.
And
How do you compare yours with others? Firstly, do they exist? In what form? And you have done some tables, you have shown some pictures. But is it possible to quantifiably say something? You can go back to the pictures you showed for 3-4 different methods you had compared.
yeah.
Yeah, these ones, right. So visually it means something, but is there a quantitative way of
Yeah,
saying?
quantity, yes.
Ah.
Yeah, I have shown you the tables with this.
So do you can you interpret them for me?
Yes, sir. So these are the clusters like vegetation, feed plot, settlement, major road, water body, canal, all roads, open land. So by using this technique, we have got percentage of total number of pixels from the total image.
Correct. That's right.
Suppose one image is 100 pixels are there, but in the output we have got 19% of the pixels
Correct.
by using this.
By that method,
Yeah,
something else,
yeah,
something else. So
yeah.
who is better now? I don't know. But you have to tell me now.
So,
The least is better.
but you
than
cannot
the
say,
highest.
we cannot say for all this X is
Take
better.
one row. Take any one
Suppose
row. and
suppose for vegetation, sir, here it is showing 19%,
Correct.
and here it is showing 36%,
Correct.
and here it is showing 25.74.
They are very close.
So this is, we can say that the ML algorithm is better for vegetation.
But it could go on the error side also, right? How do you interpret? That's what I wanted to know. Maybe 19 is best or 36 is best. Maybe the other ones are not so accurate.
Yeah.
Or maybe 25 is the best.
What we are expecting here is that suppose my area is 100%, then I should get maximum 100%.
That's
So
that is
that means of the area.
correct.
But here some area is already defined that it should contain some 50 pixels out of area. This is the percentage actually.
Correct, correct.
So from that image, what we are getting.
Correct, correct.
So similarly like that,
Time it takes to classify one image, which could have pixels like the ones we have shown on the last row. Roughly. Did you time or you did not?
first thing we have to develop the signatures. If that
No,
task
so
is
you
not-
do everything. How much computer time it takes?
it will take hardly, it depends on the size of the image again. Suppose we consider the average size, like, so the image what we have considered is having at least 20 MB of the size, and from the 100 into 100,000, 10,000 pixels, 1 lakh pixels are there.
Okay.
So it is hardly taking 10 to 15 minutes sir, for getting
These
the
are
output.
much more than that. See, this is how much. This is about
Yeah,
13 lakhs.
like it will take more than 1 hour.
More than 1 hour.
So if the image is less, then it will take less. So again, we have to go for the performance. What is the hardware, what we are having, clustering and Xeon processor and multi-core architecture.
Multiple.
Then we have to go for that graphics and all that.
No, that's
Yes,
okay.
yeah.
That's not part of the
Yeah.
thesis. The other question I have is, suppose I take an image today, the same areas of interest. I wanted to see some examples of these rules, if you have any. Or if you can. These are some of them. So let me see. So what are these? These are fixed constants, G1, G1, etc. are known.
Yes, sir. So actually, this.
That is not correct. I should go and do something else.
Mhm.
Does it ever happen, or you also the greedy approach?
No, we have
leads
check-
to the
no, no,
solution.
we have, for this, what we are doing here is that we are overlaying at the backdrop
Correct.
the satellite image,
Okay.
and the vectorized output we are overlaying over that.
Hmm.
So then by observing whether that building is accurately what we are expecting, 30 by 30 square meter is there. So but then when we switch on and off, so we can see that this building is lying below that parcel. So there is a technique for overlaying those features into that. So then only we can decide that this is the corrections what we have made into the by removing those errors is correct or not. So we have to do the I have done the cross check for each and every desired output.
Is there any further final check once you produce this map, or that's it? Is there a map level check also, which can say whether this map is accurate or not? Your last stage.
For this again we can go to the field and check GPS data whether that data what you have outputted is correct or not.
So you don't have a contribution slide in your presentation? You have or? I'm sure you would have written, you write in your thesis, right? What are your essential contributions? I want the copy. publications you are given, which you, in your opinion, is the best, has the best results? 1, 2, 3, 4.
So the first one.
The Journal of Scientific Engineering Research.
So that is the contribution of my whole research.
How big is this paper? How many pages?
This is of 14 to 15 pages.
Has pictures and everything, right?
Yeah.
I'm through. If anybody else, whatever is your protocol, you can take over.